Hi, my name is Zahidul Islam, and this is our project. The project title is an interpretable multitask deep learning framework for multi-use water quality index predictions. And first of all, from where we need to collect our data. This is the dataset site. This is the catchment data. You can easily access using this link. And after that, you can click any type of places where you can see the lake or water, and you can download the data using the PDF or Excel file. If you want map, or you can collect the data. So after collecting the various data from the places, and we have merged it and uploaded it in the Google Drive, and you can see the features, and we also see the null value. We have already checked, and also we have done a lot of things on the raw data because it is raw data, and this is the heat map of the data, and this is the horizontal block spot. You can see the outlier, and also we have done pairwise plot, Bayesian plot, distribution plot, and a lot of things. But this is these things we do because our data is collected from different places. So first of all, we need to calculate the water quality indexing from this data. So I'm going to these places. So this is the water quality from scales, because we pivot our data, and you can easily we calculate the water quality indexing by these two papers. First of all, we calculate the industrial water quality indexing. Here is the method how we can calculate, and this is the method. This is the parameters, the weight, and this is the values. And after that, we have collected our calculated our water quality indexing based on the excellent, good, and moderated. And rest of the things we have done from the same things, and we also see the industrial water quality scores. We can see, and some of the references you can easily calculate this. And from the above, we also calculate the irrigation, water quality, aquatic calculation. Finally, we get our final data set. And after that, and this is the final data set. After that, we also need to prepare our data. So we need EDA before going to the machine learning model. So we done some EDA there, and this is the data. This is the features, and we have removed our missing values, and we can see this is the heat map of the data set, and this is the outlier. So we need to remove our outlier, and is the distribution plot and the Bayesian plot we have done. So we have do a lot of things of our data set, and here we have missing blocks. We have analysis, data conversion, because we need to remove our outliers. So this is the outlier detection treatment using the Z-score normalization. You can easily see that we have removed our outliers, and after that we do some engineering features, two features we have done, and created two new features from these equations. You can see easily the value of these two things, and then we data normalization and scaling we have done using the min max, and this is the range of our data we can easily see, and this is the final data sets. Thank you. To all rest of the things will continue to raise up.
Everyone, my name is Rajal Karim. I'm the team lead of this project. I'll be presenting the proposed method. So whole code is modular by different functions which could be executed through main function call. So here first is import all library functions, where it has different imports such as numpy, pandas, which will be used for numerical operation, load and manipulating data sets. Scikit-learn will be used for split data, normalized features, and TensorFlow and Keras will be used for build and train deep learning models. So this is the load data function, which can load a dataset using a specific path. And this is the pre-process function, where we split the dataset into 80%, 20%, 80% for training and 20% for testing, and normalized using standard scalar build model function, where input layer make the input feature into sequence for LSTM layer. So LSTM encoder has two LSTM layer. First is LSTM1, which has 64 neurons, and return sequence is true as its output could be used for the next layer. Here is the multi-head attention layer with 4 heads, where each head learns different relationship. Use layer normalization, which epsilon 6 used for avoiding divided by 0 error, and we used a dropout of 0.2, which means randomly we remove 20% of neurons during the training. The pooling, we used global average pool. In output, regression output, dense one means it provide water quality index values as regression outputs. And here's the model training, where we can fit the model for training on the features. This is the main function, where we initially called the all library import, and then mounted the drive, then define the input features, regression outputs, and so on. We run the whole code, whole model in 50 epoch, and within 50 epoch, the model showed some significant result. From the result analysis, here is some curve. So due to time limitation, I will not discuss it in so detail. So here is the overall result. We can see the model achieved a significant lower scores, and each water quality index it has provided very lowest error and losses. Here we can see some predicted and output, so where we can see side by side comparison between an output. So, and here is plotting result. We can see actual and predicted plot approximate the prediction very well. And here are also some analysis. I'll not go through in detail. So we also conducted a baseline comparison with existing method. So here is transformer based model, and I'll not go through in detail. See the transformer model has a larger error than the proposed model. So conducted comparison with classical machine learning such as ridge regression, lasso regression, linear regression, decision tree, random forest, extreme gradient boosting. Results are outperformed by our proposed method. So here we conducted a single water quality index analysis where we observed in single task and multitask water quality prediction using the existing baseline models. And we already saw from the comparison table in the presentation that our proposed model outperformed the existing model. So that's all. Thank you for watching.